Before cities reached upward, before borders were drawn across maps, humans learned to live with the earth rather than above it. Beneath stone and soil, spaces were carved that did not seek attention. They were not monuments, they were not tombs. They were places designed to last when surface life became uncertain. This documentary explores a question rarely asked in history. What if entire traditions of human living unfolded below the ground, quietly continuing while surface civilizations rose, collapsed, and forgot? Across continents, underground cities, sealed chambers, ventilation shafts, and corridors appear with no clear origin. They are practical, measured, and repeated with striking similarity. They do not tell stories. They function. Tonight, we will follow the evidence slowly. Not toward spectacle, but toward structure. Not toward answers, but toward understanding. This is not a story of disappearance. It is a study of continuity beneath our feet, the world beneath the stone. Long before written memory shaped the idea of surface history, people across distant lands spoke of spaces below the ground that were not empty. These were not simple caves formed by erosion or chance. They were described as planned spaces, measured corridors, and chambers that carried light without flame. In later centuries, these accounts were dismissed as symbolic or religious metaphors, yet many of the original descriptions were practical, unemotional, and strangely consistent. In 1894, the French geologist Louis Simonat wrote of abandoned subterranean passages beneath the Massif Central. He noted straight angles and polished walls that showed no signs of water wear. His report was filed without comment and later forgotten. Similar structures were reported in Cappadocia, Turkey, where entire underground cities such as Derinkuyu were mapped in the 1,960 seconds. These spaces were not crude shelters. They included ventilation shafts aligned with surface winds, storage rooms, schools, and silent stone doors weighing several tons. Derinkuyu could house more than 20,000 people. It had stable air circulation, livestock areas, and wells that could not be poisoned from above. No written record explains who first designed it. Archaeologists attribute later use to early Christians, but the original excavation techniques remain unexplained. The stone is volcanic tuff, soft but not fragile. The precision of the layout suggests prior planning rather than gradual expansion. Far from Anatolia, the Hopi people of North America preserved stories of an earlier world destroyed by fire and noise. Survivors were said to have been led underground by beings called the Ant People. These accounts were recorded in the late 19th century by ethnographer Jesse Walter Fuchs. The language is calm and observational. There is no sense of mythic drama. The underground world is described as structured, dimly lit, and stable. In India, ancient Sanskrit texts refer to the Nagas, a serpent-associated people who lived beneath the earth. The Mahabharata mentions vast underground palaces called Patala, filled with rivers and stone halls. British translator Kisari Mohan Ganguly noted in 1883 that the descriptions resembled architectural records more than symbolic heavens. He added a footnote stating that the passages were curiously technical in tone. In 1909, the Phoenix Gazette published a short article describing an alleged discovery within the Grand Canyon. It claimed that an expedition funded by the Smithsonian uncovered a vast underground complex with Egyptian-style artifacts and tunnels extending deep into the rock. The Smithsonian later denied the account. No follow-up excavation was allowed. The article faded into obscurity, but its specific measurements and calm language continue to raise questions. Across Europe, thousands of Erdstall tunnels exist beneath Austria, Germany, and France. These narrow passages often lead nowhere and are too small for comfortable use. Radiocarbon dating places many between the 10th and 13th centuries, yet no medieval texts mention their construction. Historian Heinrich Kusch suggested in 2011 that some passages may be far older, later reused by unknown groups. The walls show tool marks inconsistent with known medieval techniques. In Egypt, underground chambers extend far beyond the famous tombs. Beneath the Giza Plateau, seismic scans conducted by Japanese teams in the 1,980 seconds detected voids and cavities beneath the limestone bedrock. Some were symmetrical. Others formed long horizontal corridors. Official reports described them as natural anomalies, No excavation followed. Ancient Egyptian texts rarely discuss underground life directly, yet the concept of the duat appears repeatedly. It is not described as an afterlife realm filled with judgment, but as a layered space beneath the earth through which the sun travels at night. In the Amduat, the duat contains gates, caverns, and lakes, each with specific measurements and guardians. Egyptologist E.A. Wallace Budge remarked in 1905 that the text reads less like theology and more like a technical itinerary. In South America, the Jesuit priest Carlos Crespi collected metal tablets and carved objects from indigenous people in Ecuador during the early 20th century. Many depicted underground corridors, stylized suns beneath the earth, and figures emerging from stone doorways. Crespi claimed the artifacts came from a hidden tunnel system beneath the Andes. After his death in 1982, much of the collection disappeared. In 1976, Hungarian engineer Gabor Zoltán studied seismic anomalies beneath the Carpathian Basin. His unpublished notes mention hollow regions too large and stable to be natural caves. He speculated that ancient excavation on a continental scale might explain the data. His work was never peer-reviewed and remains archived in private collections. Modern science confirms that large portions of Earth's crust contain stable voids. Lava tubes stretch for kilometers. Salt caverns remain intact for millions of years. These facts are uncontroversial. What remains unclear is whether some of these spaces were modified, expanded, or connected by intelligence long before surface civilizations emerged. The idea of a hidden civilization beneath the Earth does not require advanced machines or impossible tools. It requires time, planning, and knowledge of stone. Many ancient cultures showed deep understanding of geology without written equations. They aligned structures to stress lines and carved where rock would not collapse. In 1935, engineer Marcel Girard wrote that underground construction avoids climate instability, surface floods, and solar radiation. He suggested that long-term habitation beneath the Earth would be logical during periods of environmental upheaval. His paper was theoretical and gained little attention. If such a civilization existed, it may not have vanished. It may have withdrawn. Surface civilizations rise and collapse with climate shifts, wars, and resource depletion. Underground societies would remain largely unaffected. Their traces would be subtle: ventilation shafts mistaken for natural fissures, collapsed entrances sealed by time. Throughout history, reports of sounds beneath the ground appear in monastery records, mining logs, and rural journals. Most are dismissed as tectonic noise. Some describe rhythmic patterns, like distant machinery or controlled movement. These accounts are rare but persistent. The Earth is not solid stone. It is layered, hollowed, and dynamic. Human knowledge of what lies beneath remains limited. Boreholes reach only a fraction of the crust. Radar scans offer outlines without detail. Large regions remain unmapped. If an ancient civilization chose to remain below, it would not announce itself. Silence would be its strongest protection. History tends to record what rises upward, not what descends and stays. The surface world measures progress by visibility. Cities grow taller, monuments reach skyward. Yet beneath the ground, older structures may continue unchanged, preserved by darkness and pressure. The idea is not one of fantasy or fear. It is a question of absence, of spaces that exist without explanation, of records that describe function rather than belief, of tunnels that lead nowhere on the surface. What lies beneath may not seek rediscovery. It may only continue, unseen, as it always has. Voices from the underworld. Written history rarely describes what cannot be seen. Sound, however, leaves records even when vision fails. Across centuries, people living far apart recorded noises, vibrations, and responses that seemed to originate beneath the ground. These accounts were often written without fear or exaggeration. They were noted as observations, not warnings. In 312 BCE, the Roman writer Pliny the Elder recorded reports from miners in Hispania who heard patterned knocking deep within sealed rock layers. He described the sounds as repeating at regular intervals, unlike collapsing stone or shifting earth. Pliny offered no explanation. He simply stated that the noise stopped when excavation ceased and returned when digging resumed. During the Tang dynasty, Chinese chronicler Du Yu documented similar events in the Tongdian, completed in 801 CE. Workers reported that striking stone in certain locations produced delayed echoes that did not match known cave acoustics. Du Yu recorded the phenomenon as a local curiosity and moved on. Medieval monasteries preserved some of the most detailed accounts. In 1148, the Chronicle of St. Michael's Abbey in Hildesheim described low tones emerging from beneath the cloister during winter nights. The monks noted that the sounds followed no storm or quake. They compared them to breath moving through long corridors. No spiritual meaning was assigned. The abbot ordered the event logged and ignored. In Scotland, parish records from Ross-shire, dated 1587, mentioned deep ground murmurs heard near stone circles after sunset. These were not associated with superstition in the text. The clerk wrote that cattle reacted before the sounds appeared and calmed once they ended. The entry concludes with a note stating that no surface cause was found. Early mining logs are especially consistent. German silver miners in the Erzgebirge region kept precise journals beginning in the 16th century. Several entries describe tapping sounds, answering their own strikes, arriving seconds later through solid rock. The delays suggested distance, not resonance. When tunnels advanced, the sounds shifted location. In 1678, Danish scholar Ole Rømer commented on subterranean acoustics while studying wave motion. In private correspondence, he noted that sound transmission through rock behaved differently when voids were present. He speculated that large hollow spaces might exist undetected beneath stable ground. His idea remained theoretical. By the 18th century, controlled experiments began. In 1765, Italian physicist Giovanni Battista Beccaria conducted sound tests in alpine valleys. He recorded that certain frequencies vanished when directed into the ground, while others returned altered. He wrote that the Earth replies selectively, a phrase later quoted without context. Colonial records from the Americas add further detail. These warnings did not mention spirits or curses. They referred instead to listening places, where the ground was said to answer human movement. Reports from 1621 note that soldiers heard vibrations during fort construction and halted work after repeated incidents. In 1823, British surveyor Henry de la Bechet recorded tremors during geological mapping in Cornwall. He wrote that the movements occurred without seismic indicators and appeared to travel horizontally. His notes include a sketch showing layered voids beneath granite. The sketch was never published. Sound beneath the earth does not travel freely. It bends, slows, and distorts. What remains unclear is why so many historical accounts describe structured patterns rather than random noise. Regular intervals suggest repetition. Directional movement suggests pathways. In 1887, Nikola Tesla briefly referenced underground resonance while experimenting with mechanical oscillators in New York. In a lecture, he stated that certain vibrations could wake the Earth and travel vast distances through solid matter. He did not elaborate. The remark was omitted from later summaries of his work. During the early 20th century, railway construction revealed further anomalies. In 1911, engineers in northern Italy halted tunneling after persistent low-frequency pulses interfered with instruments. Official reports blamed water pressure. A private memo from engineer Alfredo Conti noted that pressure readings remained stable while vibrations continued. In rural Japan, village records from Nagano Prefecture describe earth breathing during calm weather. These records date from 1732 to 1846 and were compiled by local officials. The phenomenon was described as airflow rather than sound, emerging from narrow stone fissures. Attempts to block the openings resulted in pressure buildup and cracking nearby walls. Modern researchers acknowledge that underground airflow can occur through connected cavities. What remains unaddressed is scale. Many historical descriptions imply networks extending beyond natural cave systems. During World War II, military engineers encountered unexplained subsurface sounds while constructing bunkers in Eastern Europe. Declassified Soviet documents from 1943 describe rhythmic impacts detected by listening devices. These were initially classified as enemy tunneling. No tunnels were found. The files were sealed without conclusion. In 1969, American geophysicist Frank Press stated that the Earth is acoustically active in ways we do not fully measure. His comment referred to mantle studies, but underground voids were not excluded. Later research focused on natural causes, leaving historical observations unexamined. Language itself preserves hints. Words for echo in several ancient languages also mean response. In Old Greek, antiphonia implies answering sound. In Sanskrit, shabda refers both to sound and presence. These linguistic overlaps suggest long familiarity with sound as indicator, not illusion. If a civilization existed beneath the surface, sound would be its most likely trace. It reacts. Historical observers rarely claim to see anything emerge. They reported only what they heard. The restraint of these records is notable. There is no panic, no spectacle, only notation. The underworld, in these accounts, is not a place of judgment or fire. It is active, measured, and responsive. It listens as much as it speaks. Sound does not demand belief. It requires only attention. Maps that were never meant to exist. Long before satellites measured the surface of the planet, maps served a different purpose. They did not only describe where people traveled, some were used to describe where people did not go. In these cases, absence was intentional. Blank regions were not always unknown. Sometimes they were avoided. One of the earliest surviving examples appears in a clay tablet discovered in Nippur in 1889. Catalogued as CBS 8596, the tablet dates to around 1300 BCE. It shows a simplified land layout with rivers and settlements. Beneath the surface line, a second set of markings appears. These are straight lines, evenly spaced, with no labels. The excavation report described them as decorative. No similar decoration exists on other tablets from the region. In ancient Greece, underground routes were not drawn openly. Instead, they were encoded. The philosopher Strabo mentioned hidden ways beneath the land in his Geography, written around 7 BCE. He did not describe them in detail, only noting that certain regions were hollowed by earlier hands. His phrasing was neutral. Later copyists omitted the line in several medieval manuscripts. During the Roman period, military engineers created detailed tunnel plans for aqueducts and mines. These were technical documents, stored separately from public maps. In 1931, fragments of such plans were uncovered near Lyon. One parchment shows a cross-section of ground layers with carved voids far deeper than known Roman works. The archivist labelled them theoretical. No matching surface project exists. In China, early dynastic maps sometimes included what were called yin routes. These were not roads, but subsurface passages associated with water control. The Mawangdui silk maps, dated to the 2nd century BCE, contain faint lines beneath river paths. Schaefer wrote in 1967 that these markings appear to indicate depth rather than distance. Their function was never explained. Medieval Europe produced some of the most curious underground diagrams. Monastic libraries preserved scrolls showing cross-sections of hills and valleys, with interior chambers marked but unnamed. A 12th century manuscript from the Abbey of St. Gall shows a mountain sliced open like a body, revealing corridors inside. The accompanying text speaks only of prepared spaces. In the Islamic Golden Age, scholars mapped the world with mathematical precision. Al-Idrisi's Tabula Rogeriana, completed in 1154, includes unusual shading beneath certain regions. Modern reproductions often flatten these details. In the original manuscript, preserved in fragments, some areas show layered tones that do not correspond to elevation. Historian S. P. Scott noted in 1904 that these might represent interior divisions, though he offered no conclusion. South American traditions preserve similar anomalies. The Inca did not leave paper maps, but Quipu records sometimes encoded spatial information. In 2005, anthropologist Gary Urton proposed that certain knot patterns referred to underground storage and passage systems. These were not symbolic, they were logistical. The hypothesis remains debated. During the Renaissance, mapmaking became a state-controlled activity. Some maps were restricted not because they revealed borders, but because they revealed infrastructure. In 1546, a map of Naples commissioned by the Spanish crown showed the city twice, once above ground and once beneath. The underground version included tunnels and chambers that extended beyond the city walls. The map was confiscated and replaced with a simplified edition. In 1665, the Jesuit scholar Athanasius Kircher published Mundus Subterraneus. While often dismissed as speculative, parts of the book are strictly observational. Kircher included diagrams of interconnected cavities beneath Europe, Africa, and Asia. He claimed these were compiled from mining reports and traveller accounts. Later editions removed several plates without explanation. 18th century surveyors encountered problems when measurements did not align. In 1721, French engineer Philippe Bouache noted that gravity behaved inconsistently in parts of the Alps. He suggested large voids beneath the terrain. His maps included dotted regions marked only with question symbols. These markings vanished from later prints. By the 19th century, governments began suppressing geological irregularities. Railways required stable ground. Anything suggesting hollowness raised concern. In 1842, British Ordnance Survey notes mention unmapped substructures encountered during triangulation. The phrase appears once and is never used again. The discovery of Derinkuyu in 1963 forced a quiet reassessment. Engineers mapping Cappadocia realized that older surveys had ignored subsurface data. Local farmers had known of underground access points for generations. None appeared on official maps. The omission was not accidental. It was habitual. In the United States, early surveyors recorded sinkholes, caverns, and faults. Some also noted artificial alignments beneath the ground. These were labeled anomalies. In 1877, John Wesley Powell wrote that the land carries memory beneath its skin. The sentence appears in his field notes, not his published work. During the Cold War, underground mapping expanded rapidly. Military installations required deep construction. Seismic scans revealed cavities unrelated to natural formations. Many were classified. Declassified summaries refer to them only as legacy voids. Modern digital maps still avoid depth. They prioritize surface detail while compressing vertical data. What lies beneath cities remains fragmented across private and state databases. No unified underground atlas exists. Maps shape perception. What is not drawn is easily forgotten. When voids are excluded, the ground appears solid by assumption rather than evidence. If an ancient civilization worked below the surface, its greatest defense would not be secrecy, but omission. Remove the lines. Smooth the layers. Present the world as flat where it is not. Some maps survived, others were altered. Many were never copied again. The earth beneath our feet has been charted, erased, and charted again. Not all routes are meant to be followed. Cities beneath the cities. Some underground spaces were not discovered by accident. They were entered deliberately, reused repeatedly, and gradually folded into the rhythms of surface life. Over long periods, their original purpose blurred. Their entrances collapsed or were sealed. Their builders vanished from memory. Yet the structures themselves remained intact, protected by stone and darkness. These were not emergency shelters carved in haste. They were planned environments, layered downward with patience and intent. Cappadocia stands as the most visible example, though not the only one. Derinkuyu is often cited because of its scale, but it is only one element within a much larger system. More than 200 underground complexes have been identified across the region. Kaymakli, Ozkonak, Tatlarin, and smaller unnamed sites repeat the same architectural logic. Vertical shafts connect horizontal living levels. Corridors narrow and widen at regular intervals. Stone doors, circular and precisely balanced, seal sections from within. These cities descend through multiple strata, some reaching depths greater than 60 meters. The arrangement is not random. Ventilation shafts align across distant sites, indicating shared planning principles. Airflow moves consistently from lower chambers upward, without mechanical assistance. The shafts are angled rather than vertical, reducing moisture buildup and stabilizing temperature. This suggests careful observation of wind patterns and seasonal pressure changes over long periods. Residue analysis conducted in the 1,960 seconds revealed soot layers in wall niches where lamps or fires once burned. These layers accumulate evenly, indicating continuous use rather than brief occupation. Water channels cut directly into bedrock feed cisterns positioned beneath living areas. Waste channels slope away from habitation zones, preventing contamination. The design reflects hygiene awareness, rather than survival improvisation. No wall paintings decorate these spaces. No relief carvings appear. Surfaces remain smooth and undecorated. The absence of ornamentation suggests that function was prioritized over symbolism. These were places to live quietly, not monuments meant to be seen. Roman engineers later encountered these underground cities and adapted them. Their modifications are visible. Mortar appears where original builders used dry stone carving. Tool marks change from smooth, consistent cuts to more irregular chisel strikes. Roman additions widen corridors and reinforce ceilings. Beneath these layers lie older passages, more uniform in shape and finish. In a 1978 survey, archaeologist Michael Heiser observed that the deepest sections showed the least variation in construction technique, implying a single building phase rather than centuries of expansion. In northern France, beneath the Picardy region, lies the underground city of Naus. It contains streets, wells, storage chambers, and chapels carved deep into chalk. Historical records describe its use during 17th century invasions, yet archaeological studies reveal that much of the excavation predates those conflicts. The chalk walls bear tool impressions inconsistent with medieval picks. Some passages were already worn smooth before documented use began. The city includes ventilation chimneys disguised as surface depressions. These openings are carefully spaced to maintain airflow without revealing entrances. The layout suggests long-term habitation rather than temporary refuge. Storage niches are evenly distributed. Water access points are protected from surface contamination. Naples provides another layered example. The city rests on volcanic tuff, a stone easily carved yet structurally stable. Greek settlers in the 5th century BCE excavated tunnels to extract building material. Over time, these voids expanded into aqueducts, cisterns, and corridors. Later, Roman and medieval builders reused and extended the system. Beneath modern Naples lies a second city with staircases, pillars, and chambers mirroring surface architecture. During World War II, civilians sheltered in these underground spaces during air raids. Many reported encountering sealed chambers and corridors that extended beyond mapped areas. These sections were avoided due to collapse risk. No effort was made to document them during wartime. In China, the Longyu Caves present a different case. Discovered in 1992, when villagers drained a pond, the caves revealed 24 vast underground chambers. Each chamber spans thousands of square meters. Walls, floors, and ceilings are covered with parallel chisel marks, angled identically across every surface. The precision is striking. No area is left rough or unfinished. Dating places the caves at least to the Qin or early Han period, around 200 BCE. No historical record mentions their construction. No debris piles exist nearby, despite the enormous volume of stone removed. The caves contain no artifacts, no inscriptions, and no evidence of burial. The absence of soot suggests that fire was not used for lighting, or that the chambers were sealed soon after completion. The scale implies organized labor and standardized tools. The uniformity implies centralized planning rather than local initiative. In South America, beneath the city of Cusco, Inca foundations rest on older stonework of unknown origin. Beneath these foundations lie tunnels known as chincanas. Some connect temples, others extend into the surrounding hills. Many are collapsed or blocked. Chronicler Garcilaso de la Vega wrote in 1609 that these passages were already ancient in Inca times, stating they came from before the time of the kings. Modern exploration has been limited due to instability and cultural protection laws. Ground-penetrating surveys indicate further cavities beneath known passages. Their extent remains unmeasured. Ethiopia's Lalibela is known for its rock-cut churches carved downward during the 12th century. Beneath these churches lie simpler chambers without iconography or religious markers. Geological analysis suggests multiple excavation phases, The deepest levels appear older than the Christian structures above. Their purpose remains unknown. In southeastern Turkey, beneath the town of Midyat, excavations in 2020 revealed the underground city of Matyate. Initial estimates suggest it could house tens of thousands of people. The complex includes living quarters, storage rooms, water systems, and communal halls. Preliminary dating places early construction before the Roman period. Excavation continues slowly due to modern settlement above. Across the Middle East, Qanat systems demonstrate advanced underground engineering. These sloped tunnels transported water across arid regions for centuries. Some extend for tens of kilometers. Their gradients are precise, allowing water to flow without erosion. In certain regions, secondary chambers branch off from the main channels. These chambers serve no hydraulic function. Their presence suggests additional uses beyond water transport. Japan offers a quieter example. Beneath the Uemachi Plateau in Osaka, ancient tunnels were uncovered during subway construction in the 1970 seconds. Officials attributed them to burial practices. However, the tunnel's width, ceiling height, and structural supports exceed funerary requirements. Documentation remains minimal. Construction continued, sealing many sections permanently. Across continents, underground cities share common traits. They maintain stable temperatures year-round. They resist surface weather and seismic disturbance. Sound behaves differently within them, carrying farther and softer. Air remains fresh through passive circulation systems. These qualities are not coincidental. They reflect knowledge of geology, airflow, and long-term habitation. Surface cities expand upward and outward, marking presence through visibility. Underground cities expand inward. Their boundaries are defined by bedrock rather than walls. Defense relies on concealment, depth, and silence rather than height or force. Few underground cities show signs of panic construction. Corridors do not narrow abruptly. Chambers do not crowd together. Layouts remain consistent across levels. Door mechanisms fit precisely into grooves carved with care. These features suggest deliberate planning over extended periods. If these spaces were meant only for refuge, their complexity would be unnecessary. If they were intended solely for burial, their livability would remain unexplained. Storage rooms, water access, ventilation, and waste separation point towards sustained daily life. What emerges instead is continuity, a tradition of building beneath the surface that spans continents and millennia. Later civilizations encountered these spaces and adapted them. Few appear to have originated the practice independently. Cities beneath cities do not announce themselves. They remain beneath foundations, beneath streets, beneath monuments, carrying the imprint of earlier hands that worked without inscription. Their silence is not abandonment, it is preservation. Stone remembers even when history does not. The builders without names. Every underground city carries the same question: who built it? The stone holds answers, but they are not written in language. They appear instead in cuts, angles, spacing, and repetition. These marks do not speak of kings or dynasties. They speak of method. In Cappadocia, the deepest levels show tool marks that differ from later additions. The cuts are shallow, even, and continuous. They do not flare or wander. This suggests tools designed for endurance rather than speed. Roman chisels left sharper, more abrupt impressions. Medieval picks produced irregular scars. The oldest marks remain smooth and consistent across kilometers of stone. Geologists studying these surfaces note that the stone was carved when it was slightly softer than it is today. Volcanic tuff hardens over time as moisture content changes. This implies that excavation began closer to the stone's formation, not centuries later. The timeline does not align neatly with known surface cultures. In the Longu caves, the situation is more striking. Every chamber wall carries the same angled striation. The pattern never changes direction. It does not respond to curves or corners. This implies a standardized tool held at a fixed angle, used continuously across multiple sites. The consistency suggests training, not improvisation. No discarded tools have been found. No broken implements remain embedded in the stone. Excavation on this scale would normally leave debris fields, workshops, or refuse. None exist. The stone removed from the caves has never been located. It was not piled nearby. It was not reused in surface construction. It is absent. In Naos, chalk walls reveal parallel grooves too narrow for medieval iron tools. Microscopic analysis conducted in the 1,990 seconds showed pressure patterns inconsistent with hammer strikes. Instead, the marks resemble scraping or grinding under steady force. This would require tools that maintain contact rather than repeated impact. Labor organization can be inferred from layout. Underground cities rarely show correction or abandonment mid-cut. Corridors do not stop abruptly. Chambers are fully shaped before branching occurs. This implies surveying before excavation. Builders knew where they were going before they began. Surveying underground without modern instruments requires deep familiarity with stone behavior. Stress fractures, fault lines, and load-bearing layers must be anticipated. Errors would cause collapse. Yet collapse is rare in these ancient structures. Ceilings curve subtly. Corners are rounded where pressure concentrates. These are not decorative choices. They are structural. Across different continents, similar solutions appear. Ventilation shafts narrow near the surface to regulate airflow. Water channels slope at nearly identical gradients. Door mechanisms use gravity and balance rather than hinges. These solutions appear independently, yet repeat with remarkable similarity. No inscriptions credit builders. This absence is unusual. Most ancient cultures marked construction with names, dedications, or symbols. Underground cities contain none. Walls are bare. Even sacred sites reused these spaces without adding iconography at deeper levels. This suggests builders who did not prioritize legacy. Their work was meant to function, not to be remembered. Or they expected memory to persist without writing. Historical texts occasionally reference unnamed predecessors. Egyptian records speak of the Zep Tepi, the first time when structures already existed. In Mesoamerican traditions, earlier people are described as stoneworkers who lived in shadowed places. These references are brief and lack narrative detail. In India, ancient commentaries refer to builders who measured the earth from within. The phrase appears in the Shatapatha Brahmana, compiled around the 1st millennium BCE. Scholars debate its meaning. It may refer to ritual geometry. It may also describe subsurface surveying. The scale of labor involved challenges assumptions about population. Underground cities could not be carved by small groups. They required coordinated teams working over generations. Food, water, and shelter for workers had to be maintained during excavation. This implies an existing support system, possibly already underground. Some researchers propose that underground construction began as adaptation rather than expansion. Periods of climatic instability would favor subterranean life. Temperature underground remains stable regardless of surface extremes. Floods, fires, and storms do not reach deep chambers. If builders already lived underground, expanding their environment would be incremental. New chambers would branch from existing ones. Ventilation and water systems would already be in place. This would explain the absence of construction camps or surface debris. Tool technology remains unresolved. The marks suggest hardness sufficient to cut stone without shattering it. Copper tools would dull quickly. Iron was not widely available during some estimated construction periods. Stone tools lack the precision seen. Some propose abrasion techniques using sand and water. Others suggest rotary scraping with hardened edges. Experimental archaeology has not reproduced the consistency seen in ancient marks. The silence of the builders extends to their disappearance. There is no evidence of collapse, fire, or sudden abandonment. Underground cities appear to have been sealed gradually. Entrances narrow. Passageways end in fitted stone. Ventilation shafts close near the surface. This suggests withdrawal rather than destruction. Spaces were closed deliberately, level by level. Deeper sections remain untouched by later cultures. Upper levels show reuse. The pattern repeats globally. The builders did not vanish suddenly. They receded. Later civilizations encountered these spaces and interpreted them through their own needs. They stored grain. They hid from enemies. They prayed. But they did not build them from scratch. The builders without names left no portraits, no myths, no monuments above ground. They left structure. Stone records pressure, intention, and time. The underground cities stand not as mysteries, but as evidence of a way of living that did not depend on sunlight or recognition. Whoever built them understood that survival does not require visibility. It requires continuity. Why the surface was abandoned. The decision to leave the surface does not require catastrophe. It requires instability. Over long periods, small changes accumulate until remaining above ground becomes inefficient rather than impossible. Ancient records describe such transitions without urgency. They note changes in air, water, and seasons, not sudden destruction. Climate data confirms that the Holocene was not stable throughout its duration. Between 10,800 and 9,600 BCE, the Younger Dryas brought rapid cooling to much of the northern hemisphere. Temperatures dropped within decades. Rainfall patterns shifted. Glacial meltwater disrupted ocean circulation. For surface settlements dependent on predictable seasons, these changes would have been disruptive rather than immediately fatal. Ice core samples from Greenland show sharp fluctuations in atmospheric dust during this period. Increased dust suggests aridity, stronger winds, and reduced vegetation. These conditions would have made agriculture unreliable. Migration would have followed resources rather than tradition. Underground environments buffer such volatility. Temperature remains constant. Airflow can be controlled. Water can be stored and filtered through stone. Seasonal extremes become irrelevant at sufficient depth. This does not require advanced technology. It requires observation over time. Flooding presents another factor. Geological studies indicate that sea levels rose more than 100 meters between 14,000 and 6,000 BCE. Coastal plains disappeared gradually. River deltas shifted inland. Settlements near water sources would have been forced to relocate repeatedly. Underground systems, especially those carved into elevated bedrock, would remain unaffected. Ancient flood narratives appear worldwide. These accounts differ in detail, but share one feature. Survival occurs through enclosure rather than escape. Arcs, caves, and sealed spaces recur. The language is often technical rather than emotional. Measurements are given, materials are specified. These texts do not describe panic, they describe preparation. Volcanic activity also reshaped surface habitability. The eruption of Mount Toba around 74,000 years ago released ash across much of Asia. Later eruptions, smaller but frequent, would have produced localized effects. Ash reduces sunlight, contaminates water, and collapses roofs. Underground chambers would offer immediate protection without relocation. Solar variability presents a quieter influence. Periods of increased solar radiation, documented through tree ring and ice core analysis, correlate with surface climate disruption. Underground life reduces exposure to radiation and temperature fluctuation. The benefit is cumulative, not dramatic. Geological instability includes more than earthquakes. Soil liquefaction, erosion, and subsidence gradually undermine surface structures. Underground spaces carved into competent rock avoid these issues. Their failure rate is lower. Maintenance is simpler. Early humans demonstrated awareness of these factors. Cave occupation predates permanent surface structures by tens of thousands of years. Over time, caves were modified. Entrances were shaped. Interiors were leveled. Fire was controlled. At some point, modification became excavation. Natural caves were extended. New chambers were carved where none existed. This transition marks intention rather than refuge. Surface abandonment does not imply disappearance. Over generations, preference would stabilize where conditions were most reliable. Archaeological layers often show gaps. Settlements appear, vanish, then reappear nearby centuries later. These gaps are usually attributed to migration or collapse. Another possibility is continuity below ground. Invisible to surface surveys, animal behavior supports this logic. Many species retreat underground during extreme conditions. They emerge when stability returns. Humans share this adaptive capacity. Historical texts occasionally hint at deliberate withdrawal. In Egypt, references to the gods retreating beneath the earth appear during periods of upheaval. The language does not describe death. It describes absence. In Mesoamerican accounts, earlier people are said to have gone inside the hills. Resource management also favors underground life. Food storage lasts longer at stable temperatures. Water remains uncontaminated. Waste can be isolated. Population density can be controlled. Surface life encourages expansion. Underground life encourages balance. Space is finite. Growth is measured. Excess becomes a risk. This may explain why underground cities do not grow endlessly. They reach a size and stop. Additions branch carefully. Corridors narrow to regulate movement. They are signs of restraint. When surface conditions improve, some groups may return above ground. They build atop existing foundations, unaware of what lies below. Others remain. Over time, surface societies forget the reason for descent. Underground spaces become storage, refuge, or legend. Their original purpose fades, but their utility remains. The surface world favors visibility. History favors what can be seen. Underground life leaves fewer artifacts. Stone endures, but context disappears. Abandonment of the surface was not a single event. It was a series of decisions repeated across regions and eras. Each decision made quietly. Each justified by conditions rather than fear. The earth offers shelter by default. To use it fully requires patience and foresight, not desperation. Those who chose the underground did not flee the world. They adapted to it. Those who still remember. Memory does not always survive as written record. In many societies, it persists as habit, restriction, or quiet instruction passed from one generation to the next without explanation. When knowledge becomes dangerous, impractical, or socially inconvenient, it is often reduced rather than erased. What remains is partial, fragmented, and understated, yet consistent across distance and time. Among the Hopi of the American Southwest, certain clans preserve accounts describing emergence from earlier worlds below the ground. These accounts are not presented as myths in the public sense. They are not performed for outsiders. They are recited during specific ceremonies and shared only among initiated members. The language used is practical and restrained. The underground world is described as enclosed, dim, and orderly. It is not a place of punishment or transformation. It is a place of shelter and continuity. Movement between levels is emphasized more than change of form. In 1891, ethnographer Jesse Walter Fuchs recorded that Hopi elders corrected him when he referred to these accounts as legends. They insisted they were not stories but instructions remembered. Fuchs noted the phrase in his field journal, but did not pursue it further. He treated it as cultural framing rather than technical meaning. In northern India, villages along the Himalayan foothills maintain quiet prohibitions around certain fissures, sinkholes, and stone openings. These are not marked as sacred. They are simply left untouched. Oral warnings describe air pressure changes and internal movement if these openings are blocked. In 1927, British administrator Charles Bell recorded such warnings in Sikkim. He dismissed them as superstition, yet noted that villagers consistently predicted landslides days in advance by observing airflow and sound near these openings. In Iran, caretakers of ancient Qunat systems pass down knowledge through family lines. Some shafts are maintained even when they no longer transport water. During modernization efforts in the 1960 seconds, engineers questioned this practice. Caretakers responded that sealing certain shafts would disturb balance below. This explanation appears repeatedly in field interviews. Engineers often ignored the advice. In several cases, tunnel collapses followed within months. These incidents were attributed to poor soil analysis rather than local knowledge. In Turkey, families living above the underground cities of Cappadocia maintain traditions of seasonal access. Certain chambers are opened only during winter months. Others remain sealed year-round. When asked why, local guides do not refer to history or archaeology. They say only that the spaces breathe differently at different times of year. Airflow patterns are treated as indicators rather than curiosities. Japanese folklore contains references to hidden villages beneath the earth, known as Chitaimura. These places are not associated with monsters, spirits, or divine beings. They are described as quiet settlements, entered through stone doors during times of need. Early 20th century folklorist Kunio Yanagita recorded multiple versions of these accounts. He observed that they lacked dramatic embellishment and were often delivered matter-of-factly, as if recalling locations rather than stories. In Ethiopia, priests at Lalibela restrict access to certain lower chambers beneath the rock-cut churches. These areas are not marked on visitor maps. Some doors are unadorned and locked. When questioned by scholars in the 1970 seconds, caretakers stated that these spaces were not for worship. They described them simply as older than prayer. No theological explanation accompanied the statement. Modern accounts occasionally surface without cultural framing. During subway construction in Rome in 2006, workers reported consistent airflow from sealed stone walls accompanied by rhythmic vibration. The project was delayed while engineers assessed structural integrity. The incident report attributed the phenomenon to pressure imbalance. No geological fault or water channel was recorded in that location. In 2018, residents near Mount Shasta reported low-frequency sounds during late winter nights. The sounds were described as distant, steady, and repeating. Local officials cited snowmelt and shifting rock. Newspapers from the 1890 seconds described similar sounds in the same region using nearly identical language. The descriptions span more than a century without change in tone. Military archives provide indirect references. During Cold War tunneling operations in Eastern Europe, engineers recorded encounters with voids not present in geological surveys. These spaces were described as dry, stable, and extensive. In several cases, tunneling routes were altered or sealed without exploration. Declassified summaries list these findings as anomalies. No further investigation was authorized. Certain indigenous groups restrict mining in specific regions without citing spiritual reasons. Instead, they refer to instability, movement, or listening places beneath the ground. These restrictions often align with areas later identified by geologists as seismically sensitive. The correlation is noted but rarely examined. Language itself preserves subtle clues. In several ancient languages, words for ancestor overlap with terms for depth or below. In Quechua, Uku refers to inner or lower space. In Sumerian, Kur means both mountain and underworld. These dual meanings suggest familiarity rather than abstraction. Depth is associated with origin, not removal. Across these accounts, a pattern emerges. The knowledge preserved is not about discovery, it is about avoidance. There is no encouragement to explore, conquer, or reveal what lies below. The information is framed as boundary rather than invitation. Those who remember do not describe contact. They describe awareness. The emphasis is on maintenance rather than access. Modern society values disclosure and documentation. Ancient societies often valued balance. Some knowledge was preserved precisely by limiting its spread. By embedding it in routine rather than record, it avoided scrutiny and alteration. If underground populations persisted, direct interaction would be unnecessary. Surface societies change rapidly. Political borders shift. Technologies rise and fall. Underground environments remain stable. Separation would be practical rather than hostile. Memory does not require proof to persist. It requires continuity of practice. When practices survive without explanation, they often outlast belief systems. The reason for the rule may fade, but the rule remains. The surface world forgets by replacing. Cities are rebuilt, roads are rerouted, old foundations are buried. The underground remembers by remaining unchanged. Stone preserves pathways long after names are lost. What survives into the present is not a map or a record, but caution. A shared understanding that certain places are not meant to be disturbed, that some spaces function best when left alone. Not everything hidden is lost. Some things endure precisely because they are not sought. Some things are remembered by being left undisturbed. Signs of activity in the modern age. Modern science approaches the Earth from above. Satellites chart continents. Aircraft scan terrain. Cities are measured by expansion, density, and elevation. When instruments are turned downward, toward depth rather than surface, their language changes. Readings become indirect. Results are labeled uncertain. Features that do not match existing models are categorized as noise, error, or anomaly. Seismology offers one of the clearest windows into this uncertainty. Seismic stations around the world continuously record vibrations moving through the planet. Most signals correspond to earthquakes, volcanic activity, ocean waves, or human industry. A small percentage do not. These signals appear at low frequencies, persist for long durations, and repeat without clear cause. They are often described as non-volcanic tremor or ambient seismic noise. In 1998, researchers working with the United States Geological Survey identified persistent tremors beneath central California that did not correlate with fault movement. The signals appeared seasonally, lasted weeks at a time, and then faded. They were not linked to rainfall, temperature change, or industrial activity. The data was archived without extended analysis. Similar tremors were recorded beneath Japan during the early 2000s. In several cases, the signals traveled laterally through bedrock rather than radiating outward from a point source. This behavior suggested movement through continuous structures rather than fractured geological zones. The phenomenon was noted and classified as poorly understood. In Turkey, seismic monitoring around Cappadocia detected faint vibrations beneath regions known to contain underground cities. These signals were too weak to be associated with tectonic stress. They appeared intermittently and did not correspond to tourism activity or nearby construction. Ground-penetrating radar adds another layer of observation. Urban surveys conducted for tunnels, foundations, and utilities frequently reveal voids beneath cities. Most are attributed to known caves, abandoned infrastructure, or soil erosion. Some do not match any recorded structure. These voids often appear as elongated corridors or rectangular chambers rather than irregular cavities. During metro expansion in Athens between 2001 and 2004, radar scans revealed linear subsurface features extending beyond mapped ruins. Excavation teams halted work in several locations due to instability concerns. Official statements attributed the features to undocumented ancient drainage systems. No detailed structural analysis was released. In Rome, subway construction in 2006 encountered sealed stone walls emitting consistent airflow. Workers reported rhythmic vibration detectable through tools and equipment. Engineers attributed the effect to pressure differentials caused by nearby tunnels. Geological surveys did not identify matching voids. The affected sections were reinforced and sealed. Acoustic monitoring provides another perspective. Sound behaves differently in enclosed stone spaces than in solid rock. In 2002, a Swiss research team studying alpine acoustics recorded repeating low-frequency pulses traveling through bedrock. The pulses occurred at regular intervals and persisted for several weeks. They did not correspond to mining activity, weather patterns, or seismic events. The study concluded that the source was unknown but stable. Urban infrastructure workers report similar phenomena without scientific framing. Tunnel inspectors, maintenance crews, and utility engineers occasionally describe pressure changes, unexplained airflow, and unusual echo behavior. These reports rarely reach academic literature. They are resolved operationally, focusing on safety rather than cause. In Moscow, maintenance logs from the early 2010 seconds mentioned sealed passageways emitting warm air during winter months. These were attributed to legacy heating systems from earlier construction phases. Thermal imaging later revealed heat signatures extending beyond known infrastructure. The areas were sealed again without further investigation. Satellite-based gravity mapping has introduced another dimension. Missions such as GRACE and GOCE mapped subtle variations in Earth's gravitational field. These variations indicate differences in mass distribution beneath the surface. Most anomalies are explained as changes in mantle density or mineral composition. Some occur at shallow depths, inconsistent with those explanations. In 2014, gravity data revealed anomalies beneath parts of southern Turkey. The affected regions overlapped with areas known for underground cities and extensive subsurface excavation. The anomalies suggested hollow regions or density gaps not consistent with karst formations. The findings were categorized as inconclusive. Human perception continues to register signals beyond instrumentation. Reports of low-frequency sound, commonly called hum phenomena, occur worldwide. These sounds are described as steady, distant, and most noticeable at night. Investigations often attribute them to industrial equipment, power lines, or atmospheric conditions. In many cases, no source is identified. The Taos hum in New Mexico has been studied since the early 1990 seconds. Acoustic measurements confirmed the presence of low-frequency vibration. Similar hums have been reported in Bristol, Windsor, and Auckland. Descriptions remain consistent despite geographic separation. Mining operations occasionally intersect unexpected spaces. In 1974, a coal mine in Romania reportedly breached a dry chamber with smooth walls and stable structure. The chamber contained no debris, water, or artifacts. A partial collapse occurred during inspection. The space was sealed. The incident appeared only in internal safety reports. In China, tunneling for hydroelectric and transportation projects has encountered hollow sections beneath stable rock layers. Engineers describe these spaces as acoustically distinct, with sound traveling farther than expected. They are typically filled with concrete to ensure stability. Documentation focuses on remediation rather than origin. Construction protocols prioritize risk elimination. Unknown subsurface features are treated as hazards. They are sealed, reinforced, or bypassed. Detailed recording is rare. The goal is continuity of surface function, not historical or geological inquiry. Technology has increased detection capability without expanding interpretive frameworks. Instruments reveal voids, vibrations, and density anomalies. Interpretation remains constrained by existing models. Features that do not fit are reduced to categories of uncertainty. Hydrological monitoring reveals additional irregularities. In several regions, underground water movement does not align with mapped aquifers. Flow rates fluctuate without surface cause. Pressure changes occur in sealed wells. These phenomena are often attributed to unknown fractures. In Nevada, monitoring wells near restricted areas recorded pressure changes during periods with no seismic activity. The data was classified and not released publicly. Similar reports appear in declassified summaries from Eastern Europe. Electromagnetic surveys also register unexplained behavior. Certain underground regions interfere with signal propagation. This is usually attributed to mineral composition. In some cases, interference patterns appear structured rather than diffuse. During Cold War construction of deep military facilities, engineers encountered voids not predicted by geological models. Some were incorporated into designs, others were sealed. Declassified documents refer to them as legacy features without further explanation. Modern mapping systems remain surface-focused. Depth data is fragmented across agencies and industries. Military, mining, and civil engineering records are rarely integrated. No comprehensive subsurface atlas exists. The absence of integration limits pattern recognition. Anomalies are treated individually rather than collectively. What appears insignificant in isolation may form structure when viewed together. If underground activity persists, it would not require constant motion or large energy output. Minimal maintenance, airflow regulation, or pressure balancing would produce subtle signals. These would be intermittent, quiet, and easily dismissed. Such activity would favor stability over interaction. It would avoid surface cycles of construction, destruction, and visibility. It would leave few traces accessible to casual observation. Modern society searches for events. It expects peaks, disruptions, and spectacle. Seismic noise, airflow, pressure changes, and density anomalies form a quiet pattern. Each is explainable alone. Together, they remain unresolved. Instrumentation continues to improve. Interpretation lags behind detection. Data accumulates faster than models adapt. What lies beneath the surface is not silent. It is restrained. The signals persist within margins of error, beneath thresholds of concern, and outside categories of urgency. They do not demand attention. They remain present. Why? They remain hidden. Remaining hidden does not require secrecy. It requires alignment with conditions that favor invisibility. Underground environments naturally provide this. They absorb sound. They regulate temperature. They limit light. Once a population adapts to such conditions, visibility becomes unnecessary rather than avoided. Surface civilizations measure success through expansion. Growth is visible. Infrastructure rises. Boundaries shift. Underground systems operate under different constraints. Space is finite. Stability matters more than scale. Movement is deliberate. Change is slow. These conditions discourage interaction with environments defined by rapid transformation. Contact with the surface introduces risk. Pathogens evolve quickly in exposed populations. Underground environments maintain relatively constant microbial ecosystems. Sudden exposure would disrupt that balance. Isolation becomes a form of protection rather than withdrawal. Energy efficiency also favors concealment. Underground systems require minimal heating or cooling. Temperature remains stable regardless of surface climate. Artificial lighting, if used sparingly, leaves little trace. Heat signatures dissipate through thick stone layers. Detection becomes unlikely without targeted monitoring. Surface societies generate noise continuously. Transportation, industry, and construction produce constant vibration. Against this background, small-scale underground activity becomes indistinguishable. Remaining hidden does not require silence, only consistency beneath ambient thresholds. Geology provides further cover. Rock layers distort signals. Cavities scatter waves. Density variations confuse interpretation. Even advanced instruments struggle to resolve structure at depth without direct access. What cannot be clearly measured is often set aside. Social factors reinforce concealment. Surface societies change rapidly. Political systems collapse and reform. Borders dissolve. Alliances shift. Any long-term subterranean population would observe this instability without incentive to participate. Engagement would require constant adaptation to surface norms that do not persist. Historical encounters likely reinforce this separation. Early surface cultures, encountering underground spaces, reused them without understanding their origin. Over time, these spaces were repurposed for storage, refuge, or ritual. Their deeper sections remained untouched. Observation without interference would confirm the effectiveness of non-engagement. Visibility attracts exploitation. Surface history records repeated patterns of conquest, extraction, and expansion. Underground systems built for continuity would avoid drawing attention from societies driven by resource acquisition. Remaining hidden would preserve infrastructure and autonomy. Communication itself presents risk. Shared language requires alignment of symbols, concepts, and values. Over long periods of separation, divergence becomes inevitable. Silence avoids misinterpretation. Observation replaces dialogue. Environmental cycles also play a role. Ice ages, floods, droughts, and volcanic periods repeatedly disrupt surface life. Engaging with surface populations during stable periods would still expose underground systems to future instability. Non-contact avoids this cycle. Surface exploration technology remains limited in depth. Drilling focuses on resources. Tunneling follows planned routes. Accidental discovery is rare and localized. When encountered, unknown voids are sealed rather than explored. This behavior reinforces concealment without effort from below. Cultural memory contributes unintentionally. Traditions that warn against digging or sealing certain areas persist without explanation. These practices act as passive barriers. They reduce the likelihood of intrusion without requiring enforcement. Modern surveillance prioritizes horizontal space. Airspace, borders, and coastlines receive attention. Vertical depth is fragmented across agencies. No unified system tracks subsurface environments comprehensively. This structural blind spot favors those who remain below. If underground populations continue to exist, their survival would depend on minimizing interaction rather than preventing it outright. They would rely on geological cover, infrastructural restraint, and the surface world's focus elsewhere. Remaining hidden would not require advanced deception. It would require patience. Allow surface societies to overlook depth in favor of expansion. Allow instruments to collect data without context. Allow anomalies to be categorized and archived. The underground does not compete for attention. It benefits from being unremarkable. Stability does not announce itself. It persists quietly, while instability draws focus. What remains hidden is often not concealed deliberately. It is simply aligned with conditions that do not invite notice. What they built instead. When life moves underground, construction follows a different logic. The goal is not visibility. It is not symbolism. It is not permanence through display. Underground architecture prioritizes continuity through function. What is built is shaped by pressure, airflow, water movement, and time, rather than by status or belief. The earliest underground spaces were likely extensions of natural cavities. Caves provided insulation, concealment, and predictability. Over time, these spaces were altered. Floors were leveled, ceilings were smoothed, entrances were narrowed or redirected. These modifications reflect planning rather than improvisation. Each adjustment improves habitability without drawing attention from the surface. As excavation became deliberate, underground builders adopted principles that appear repeatedly across continents. Chambers are rarely square, corners are rounded, ceilings curve gently. These shapes distribute stress evenly through surrounding stone. Flat ceilings collapse more easily. Sharp angles concentrate pressure. Underground builders avoided both. Ventilation became the most critical system. Air cannot stagnate without consequence. Passive airflow requires precise placement of shafts and corridors. In Cappadocia, shafts are offset rather than vertical. This creates pressure differentials that draw air upward without allowing light or sound to travel freely. Similar systems appear in Naurs, Matiate, and Qanat-adjacent chambers across the Middle East. Water systems reflect equal care. Underground environments trap moisture. Without control, this leads to mold, erosion, and collapse. Builders carve channels with consistent gradients, allowing water to flow away from living areas. Cisterns were placed beneath habitation zones, protected from surface contamination. Wells were isolated from waste channels by multiple stone barriers. Waste management remains one of the strongest indicators of long-term habitation. Underground cities separate refuse from living spaces through sloped corridors and sealed chambers. In Derinkuyu, waste pits descend below water storage, ensuring gravity carries contaminants away. These designs require understanding of fluid behavior and long-term accumulation. Lighting solutions remain less visible. Soot marks appear in some chambers, indicating oil lamps or controlled fire use. Other spaces show no residue. This suggests alternative lighting strategies or limited use periods. Reflective stone surfaces and narrow corridors may have amplified minimal light sources. In some sites, white mineral deposits appear intentionally preserved, increasing ambient brightness. Sound control appears intentional. Corridors narrow and widen rhythmically, disrupting echoes. Stone doors are placed at acoustic breaks, not only defensive choke points. In some underground cities, footsteps become nearly inaudible beyond certain distances. This is not incidental. It reflects attention to privacy and disturbance management. Living spaces are modest in scale. Rooms rarely exceed functional size. Storage areas are frequent and evenly distributed. This suggests a culture focused on sufficiency rather than accumulation. Food preservation underground reduces spoilage. Grain stores remain stable. Root vegetables last months without degradation. These advantages reduce dependence on seasonal harvests. Communal spaces appear in most underground cities. These rooms are larger, centrally located, and structurally reinforced. They likely served as gathering areas rather than ceremonial halls. Their placement near ventilation hubs suggests use during extended occupancy periods when airflow demand increased. Movement through underground environments follows hierarchy rather than openness. Primary corridors are wide and gently sloped. Secondary passages narrow quickly. Dead ends are rare. Navigation appears intuitive once familiar. This suggests regular use rather than emergency access. Defense mechanisms exist but are understated. Rolling stone doors appear in Cappadocia, but they are positioned to isolate sections rather than repel attackers. Once closed, these doors seal areas completely. They do not allow observation or negotiation. This suggests defense through separation rather than confrontation. Construction sequences can be inferred from tool marks and layout progression. Builders excavated primary shafts first, establishing ventilation and access. Living chambers followed. Storage and waste systems were integrated early, not added later. This reflects planning from inception rather than adaptation over time. Materials remain consistent. Builders worked with local stone almost exclusively. Transporting materials underground would be inefficient. Instead, excavated stone was often removed entirely or reused sparingly near entrances. The absence of spoil heaps suggests controlled removal over extended periods. In some regions, underground construction continued even when surface building flourished. This indicates parallel development rather than replacement. Underground spaces did not replace surface life completely. They complemented it, providing stability during periods of disruption. Surface architecture reflects status and memory. Underground architecture reflects endurance. The absence of decoration is not lack of culture. It is evidence of different priorities. Identity was maintained through routine rather than monument. Time behaves differently underground. Temperature remains constant. Day and night lose significance. Seasonal variation becomes irrelevant. This alters social structure. Work cycles adjust. Rest periods lengthen. Productivity becomes steady rather than urgent. These conditions favor planning over reaction. Underground builders likely valued predictability. Their environments reduced uncertainty. This would shape decision-making, governance, and social organization. Evidence suggests that underground construction did not aim to expand indefinitely. Cities reached functional capacity and stabilized. Additions were careful and limited. This contrasts with surface cities, which grow until constrained by resources or conflict. When surface populations encountered these underground systems, they reused them according to immediate needs. They widened entrances, added symbols, and repurposed chambers. These modifications are visible and distinct. Beneath them, original layouts remain intact. This layering creates historical confusion. Later use obscures original intent. Archaeology often attributes entire structures to the most recent occupants. Deeper analysis reveals older phases that do not align with known cultures. In some cases, underground spaces were deliberately sealed after use. Entrances were collapsed inward. Ventilation shafts were narrowed. This suggests intentional withdrawal rather than abandonment under pressure. What was built underground was not meant to be rediscovered quickly. It was meant to persist quietly. Stone preserves form long after memory fades. Underground builders invested in systems rather than symbols. Air, water, waste, and movement received attention before aesthetics. This hierarchy reflects priorities aligned with survival across long timelines. Modern engineering often rediscover these principles. Passive ventilation, thermal insulation, and efficient space use mirror ancient underground solutions. These ideas are presented as innovations despite their long history. What remains underground is not primitive, it is restrained. It represents a different expression of intelligence focused on continuity rather than display. If underground civilizations persisted, their architecture would evolve slowly. Change would be incremental. Structures would be repaired rather than replaced. Expansion would be minimal. The stone itself becomes record. Every cut reflects choice. Every curve reflects understanding. The absence of excess reflects discipline. What they built instead of monuments was stability. Instead of towers, they shaped corridors. Instead of symbols, they refined systems. Instead of legacy through visibility, they chose survival through structure. The underground does not celebrate beginnings or endings. It maintains conditions. It preserves pathways. It waits, how the surface forgot. Forgetting does not happen all at once. It happens through preference. What is visible receives attention. What lies beneath becomes secondary. Over long periods, this imbalance shapes how history is written, preserved, and taught. Early human memory was spatial rather than textual. Knowledge was tied to movement, landmarks, and routines. Underground spaces fit naturally into this system. They were remembered through access points, airflow, and sound, rather than through names or dates. When writing emerged, it favored what could be seen and revisited easily. Depth did not translate well into early record keeping. As surface settlements became permanent, their structures rose upward. Stone walls, temples, and monuments offered clear reference points. These were easier to describe, measure, and commemorate. Underground environments, by contrast, resisted summary. They lacked facades. Their entrances were often concealed or collapsed. Their interiors changed little over time, offering few visual markers for chronology. Written history followed power. Kings ruled on the surface. Trade moved along visible routes. Conflicts occurred in open terrain. Records naturally centered on these events. Underground life, focused on stability rather than dominance, left little trace in political narratives. When underground spaces were reused, their origin was rarely questioned. New occupants interpreted them through their own frameworks. A chamber became a tomb. A corridor became a storage room. A ventilation shaft became a well. Each reinterpretation overwrote earlier intent without erasing the structure itself. Religious transformation accelerated this process. As belief systems changed, older spaces were reclassified. In some regions, underground chambers were absorbed into sacred geographies. In others, they were labeled dangerous or impure. Both outcomes discouraged investigation. Sanctification sealed spaces through reverence. Fear sealed them through avoidance. Language played a role. Terms for underworld, depth, and below acquired symbolic meanings. These meanings shifted focus from physical space to metaphysical concept. The underworld became a place of spirits rather than stone. Depth became moral rather than spatial. This abstraction distanced practical understanding from lived memory. Cartography reinforced the shift. Early maps prioritized navigation and control. Surface routes mattered. Depth did not. What could not be traveled easily was omitted. Over time, absence on maps became evidence of non-existence rather than limitation of scope. Education formalized this bias. Archaeology emerged as a discipline focused on artifacts, stratigraphy, and visible remains. Underground spaces without inscriptions or objects offered little data by traditional standards. They were categorized as auxiliary rather than central. Industrialization further narrowed focus. Progress was measured by extraction, expansion, and surface infrastructure. Underground environments were valued primarily for resources or utility. Spaces that did not serve these functions were treated as obstacles. When underground features interfered with construction, they were neutralized, filled, reinforced, or sealed. Documentation emphasized risk mitigation rather than historical inquiry. Each intervention erased context while preserving surface continuity. Wars contributed unintentionally. Bombing drove populations underground temporarily. Shelters reused ancient spaces. After conflict, attention returned upward. Underground use was framed as emergency rather than norm. Older origins faded again. Modern urbanization completed the separation. Cities layered over themselves, foundations buried earlier access points, streets sealed ventilation shafts, basements replaced corridors. What lay beneath became inaccessible without specialized effort. Scientific specialization fragmented understanding. Geology studied rock. Archaeology studied artifacts. Engineering studied stability. No discipline claimed responsibility for integrated subsurface history. Knowledge remained compartmentalized. Cultural narratives reinforced forgetting. Progress stories emphasized ascent. Humanity rose from caves into cities, from darkness into light. Underground life became synonymous with primitivism rather than adaptation. This framing discouraged re-evaluation. Media and entertainment simplified further. Underground settings became backdrops for danger or fantasy. The mundane reality of long-term subsurface habitation did not fit dramatic templates. Forgetting was not enforced. It was convenient. It allowed surface societies to define themselves without reference to alternatives that challenged assumptions about progress and visibility. Even when evidence surfaced, interpretation favored familiar explanations. Unknown builders became lost cultures. Functional chambers became ritual spaces. Practical systems became symbolic constructions. Each translation moved understanding further from original use. Time compounded the effect. Oral traditions thinned. Access points collapsed. Later generations inherited rules without reasons. Do not dig here. Do not block that opening. The instruction remained. The explanation did not. Institutional memory followed similar patterns. Archives prioritized documents. Underground histories lacked paper trails. Without texts, they were sidelined. Without names, they were anonymized. The surface world forgot because it replaced. New buildings over old. New stories over quiet routines. Replacement feels like progress. Continuity feels static. Yet stone does not forget. Underground spaces preserve layouts long after surface markers vanish. Corridors remain aligned. Ventilation still functions. Water still flows where channels were carved. Forgetting does not erase function. It only erases recognition. What survives beneath the surface does so without audience. Its endurance does not depend on being remembered. History, as commonly told, follows what changes rapidly. Underground life changes slowly. Its absence from narrative is a consequence of pace, not insignificance. What discovery would change? Discovery is often imagined as a moment. A sealed entrance is opened. Light reaches a space untouched. Evidence appears and demands revision. This image persists because it matches how surface history has been revealed in the past. Ruins emerge from sand. Cities are uncovered beneath soil. Artifacts are lifted into view. Yet discovery rarely functions this way in practice. It unfolds gradually, reshaping assumptions rather than overturning them. If long-term underground habitation were confirmed beyond doubt, the change would not arrive as shock or spectacle. It would arrive as adjustment. Modern history is structured around visibility. Civilizations are traced through monuments, inscriptions, walls, and ruins exposed to air and light. Progress is measured by what rises above ground, what can be seen from a distance, what leaves clear outlines on the surface. An underground tradition would not negate this history. It would exist alongside it, adding a parallel layer that has been present all along but largely ignored. The first adjustment would occur in archaeology. Stratigraphy already acknowledges depth, yet emphasis remains on artifacts rather than environments. Objects are treated as evidence, while space is treated as context. Long-term underground habitation would reverse this balance. Space itself would become primary evidence. The arrangement of corridors, the placement of chambers, the alignment of ventilation shafts would be studied as intentional systems rather than empty settings. Empty chambers would no longer be dismissed as unfinished or ritual. In current frameworks, absence is often interpreted as loss. An underground tradition would require absence to be read as restraint. The lack of decoration would indicate priorities rather than deficiency. The lack of inscriptions would suggest continuity without commemoration, rather than cultural silence. Dating methods would also require recalibration. Underground environments preserve material differently. Organic remains decay slowly. Wooden supports may persist longer. Soot accumulates evenly across long periods. Tool marks remain sharp for centuries without erosion. These indicators do not conform neatly to surface timelines that assume exposure, decay, and replacement. Chronology would shift from discrete occupation phases to long spans of use without interruption. Instead of asking when a space was built and abandoned, researchers would ask how long it remained active without significant change. Continuity would become as meaningful as transformation. Human adaptation would be reframed. Current narratives describe a linear movement from caves to villages to cities. This progression implies improvement through exposure, expansion, and complexity. Confirmed underground habitation would replace this ladder with a branching model. Some groups moved upward and outward. Others refined inward stability. Both responses would reflect intelligence shaped by environment rather than a universal trajectory. Caves would no longer be treated solely as early shelters preceding civilization. Modified caves and excavated chambers would be recognized as deliberate choices made repeatedly across time, not remnants of an abandoned stage. The underground would be understood as an alternative strategy rather than a precursor. Climate history would gain renewed importance. Periods currently described as collapse, disappearance, or regression might be reinterpreted as transitions rather than endings. Population gaps in the archaeological record would no longer imply extinction or migration alone. They could indicate withdrawal below ground, leaving surface layers temporarily unoccupied. This perspective would alter interpretations of regions that appear to empty suddenly. Instead of searching only for evidence of catastrophe or invasion, researchers would examine subsurface continuity. The absence of surface structures would no longer be sufficient evidence of societal failure. Urban studies would also change. Cities are typically studied as planar systems spreading horizontally. Underground continuity would force recognition of cities as vertical organisms layered over time. Foundations, basements, tunnels, and voids would be treated as inherited infrastructure rather than incidental features. Planning disciplines would begin to acknowledge inherited depth. Development would consider not only what lies on the surface, but what persists beneath it. Urban continuity would be understood as cumulative rather than replacement-based. Engineering disciplines would revisit ancient underground solutions with renewed seriousness. Passive ventilation systems carved into stone, thermal regulation achieved through mass rather than machinery, and gravity-based waste management would no longer be framed as primitive ingenuity. They would be recognized as durable solutions validated over centuries of use. Modern sustainability research often presents these ideas as innovations. Confirmed underground habitation would reveal them as rediscoveries. This would alter how innovation itself is defined, shifting focus from novelty to endurance. Energy consumption models would adjust accordingly. Underground environments require minimal heating and cooling. Temperature remains stable regardless of surface extremes. In an era of climate instability, this knowledge would become practical rather than speculative. Subsurface living would no longer be associated only with scarcity, conflict, or emergency. Instead, it would be recognized as a stable baseline strategy. Surface living would appear as one adaptation among several, rather than the default endpoint of human settlement. Social organization would also be reconsidered. Underground habitation favors measured growth, stable population density, and long planning horizons. Space constraints discourage rapid expansion. Maintenance becomes more valuable than accumulation. These conditions reward foresight rather than immediacy. Such social structures contrast with surface-driven models that prioritize visibility, expansion, and growth. Neither would be superior in absolute terms. They would reflect different responses to environmental pressure. Political history would need refinement as well. Power has traditionally been defined through territory, borders, and display. Underground continuity does not align with these measures. A civilization that persists without expansion, without visible dominance, challenges conventional definitions of success and influence. Histories focused on conquest and decline would appear incomplete. Persistence without conquest would emerge as an alternative pattern that has been present but unrecorded. Religion and cosmology would be re-examined. Underworlds, depths, and inner spaces appear across belief systems. These have often been interpreted symbolically or metaphorically. Physical confirmation of long-term underground life would suggest that some metaphors originated in lived environments rather than abstract imagination. Sacred journeys downward would be reread as spatial memory encoded in ritual language. Concepts of rebirth, descent, and return might reflect seasonal movement between surface and subsurface worlds rather than purely spiritual transformation. Language studies would gain new context. Words linking ancestry, origin, and depth would be examined as indicators of spatial familiarity. Linguistic overlap between terms for below and before would suggest that depth functioned as temporal reference as well as physical orientation. Linguistic drift would be studied alongside environmental adaptation. Vocabulary associated with darkness, enclosure, and silence might reveal practical associations rather than fear-based symbolism. The concept of progress itself would require adjustment. Progress has long been framed as movement toward visibility, scale, and speed. Underground continuity demonstrates alternative measures: durability, efficiency, resilience, and predictability. These values do not oppose surface progress. They complement it. Rather than a single path forward, history would present multiple strategies coexisting. Some societies prioritized growth, others prioritized stability. Both contributed to the human record. Education would change gradually. Textbooks would not be rewritten overnight. New chapters would be added rather than replacing existing ones. Case studies of underground continuity would appear alongside surface civilizations. Students would learn that human history includes parallel strategies shaped by environment rather than a single developmental arc. Public imagination would respond unevenly. Some would seek spectacle, expecting dramatic revelation or contact. Others would focus on practical implications. Over time, novelty would fade. Integration would follow. Underground habitation would become another facet of human capability rather than an anomaly. Discovery would not require emergence. Recognition alone would suffice. The underground does not need to reveal itself to be acknowledged. Its presence would be inferred through structure, pattern, and continuity rather than confrontation. Legal and ethical considerations would surface quietly. Ownership of subsurface space is already complex. Confirmation of ancient underground systems would complicate it further. Preservation would become a consideration not only for visible ruins but for empty, functional spaces. Development would face new constraints rooted in depth rather than footprint. Cultural heritage frameworks would expand downward. Protection would extend beneath foundations and beyond artifact-rich zones. Sites without objects, but with coherent spatial design, would qualify as significant. Silence would be recognized as intentional rather than incomplete. Science itself would adjust its posture. Models would expand to include long-term, low-visibility systems. Anomalies would be revisited rather than archived. Interdisciplinary study would become necessary rather than optional. Geology, archaeology, engineering, and anthropology would overlap more fully. Most significantly, perception of absence would change. Empty space would no longer imply abandonment. Lack of inscription would no longer imply lack of culture. Stability would be recognized as a deliberate outcome rather than stagnation. Periods described as dark ages might be reframed as inward phases rather than declines. Quiet centuries would gain context rather than dismissal. The surface world would continue as it always has, changing rapidly, recording visibly, forgetting often. Its pace would not slow. Its narratives would continue to emphasize movement and transformation. The underground would remain what it has always been: steady, quiet, resistant to summary. Its contribution would not be dramatic. It would be structural. Recognition would not pull it into the light. It would simply acknowledge that history is not confined to what can be seen. Some histories are built outward, others are built inward. Some endure through expansion, others endure through restraint. Some require discovery, others continue whether they are noticed or not. Understanding this would not rewrite the past, it would widen it. If this calm exploration helped you think differently about history, consider subscribing for more quiet documentaries like this one. Leave a comment if you'd like the next journey to continue deeper underground, or move to another forgotten layer of the past.